The starry sky you're looking at right now is entirely an illusion. Some of those flickering points of light actually died long before the dinosaurs went extinct, but their light is only reaching your eyes at this very moment. This is the most ruthless truth of the universe. You can never see the universe as it is now, only as it was in the past. What's even more absurd is that scientists have discovered that all matter in the universe, including every single atom in your body, came from stars that exploded billions of years ago. That's right, you are a walking stellar corpse, a product casually stitched together by the universe. And yet this corpse somehow learned to think about the universe itself. That fact alone is the greatest mystery of all. So here's the question. How did all of this begin, and how does the universe actually work? Next, take a deep breath. We're about to embark on a journey across 13.8 billion years. 13.8 billion years ago, the universe did not exist. There was no space, no time, not even the concept of nothingness. Then, in an instant faster than your blink by a trillion times, everything went from nothing to something. Scientists call that moment the Big Bang. But here's a deeply counterintuitive fact. The Big Bang was not an explosion blasting matter outward. It was space itself expanding violently, like dots drawn on the surface of a balloon as it inflates, with the distance between every point growing larger and larger. Within the first second, the universe underwent changes beyond human imagination. Temperatures reached 1 trillion degrees, hundreds of thousands of times hotter than the core of the sun. Energy continuously transformed into matter. Electrons, quarks, photons, the fundamental particles that make up your body, were born in that instant. But the truly insane part came next. Just 10 superscript 3 seconds after the Big Bang. That's a decimal point followed by 35 zeros and then a 1. The universe experienced another explosion. What does that mean? A region smaller than an atom expanded in an instant to the size of the entire observable universe. This expansion happened far faster than the speed of light. You might ask, isn't it impossible for anything to exceed light speed? That's true for matter, but not for space itself. This is the universe's first lesson to us. Its rules are far more cunning than we imagine. 380,000 years later, the universe finally cooled enough for light to travel freely. That light has been wandering the cosmos ever since. And today we call it the cosmic microwave background radiation. Here's something fascinating. A tiny fraction of the static noise on your TV screen is actually this afterglow from 13.8 billion years ago. Every day, without realizing it, you are touching the origin of the universe. Next came the long cosmic dark ages. For hundreds of millions of years, there were no light sources at all. Only clouds of hydrogen and helium drifted silently through space. Until about 13.6 billion years ago, when gravity finally worked its magic. Gas clouds began to collapse under their own weight, compressing, heating, until their cores reached 10 million degrees. Nuclear fusion ignited. The first stars were born. The universe was lit for the first time. But here's a chilling thought. These first-generation stars were absolute monsters. Some were hundreds of times more massive than the sun. They burned ferociously and lived incredibly short lives. Sometimes only a few million years. Then they exploded as supernovae. The energy released was equivalent to a star emitting all the light of its entire lifetime, in just a few seconds. And it was these violent deaths that forged elements heavier than helium, carbon, oxygen, iron, gold. Every heavy atom in your body comes from the corpse of a star. In 2024, the James Webb Space Telescope sent back a discovery that stunned the scientific community. Just 290 million years after the Big Bang, the universe already contained mature, massive galaxies. This completely shattered our expectations. According to earlier theories, galaxy formation should have been a slow process, requiring billions of years. Reality tells us otherwise. The universe moves far faster than we thought. About 13 billion years ago, the Milky Way began to take shape. Countless stars and gas clouds, woven together by gravity, slowly formed a vast spiral. Our sun, however, wouldn't be born until 4.6 billion years ago. At that time, a cold molecular cloud drifted in some corner of the Milky Way. Then a nearby star exploded, its shockwave disturbing the calm. The cloud collapsed. The sun ignited. The remaining debris collided and merged. Earth, Mars, Jupiter. The planets took shape one by one. But Earth's childhood was anything but gentle. 4.5 billion years ago, a Mars-sized body slammed directly into Earth. The impact was powerful enough to melt the planet's surface into a global magma ocean. Debris blasted into space, later coalesced under gravity to form the moon. That bright moon you see every night is actually a piece of Earth torn away by that collision. 3.9 billion years ago, Earth endured a barrage of comets. It sounds catastrophic, but those comets brought water. Oceans formed. Earth gained a cradle for life. 3.8 billion years ago, near hydrothermal vents on the ocean floor, the first single-celled life quietly emerged. For the first time, matter in the universe learned how to copy itself. This was the most critical turning point in the history of matter. Lifeless atoms spontaneously assembled into structures capable of reproduction. Even today, scientists don't fully understand how this happened. Life spent over 3 billion years, evolving from single cells into complex organisms. 540 million years ago, the Cambrian explosion flooded the oceans with bizarre new life forms. 400 million years ago, life crawled onto land. 350 million years ago, giant insects and the first reptiles appeared. Then, 250 million years ago, an unprecedented catastrophe struck. Sustained supervolcanic eruptions turned Earth into a toxic chamber. Oceans acidified. 95% of species went extinct. It was the most devastating mass extinction in Earth's history. But life always finds a way. Survivors began a new evolutionary race. Dinosaurs rose and ruled Earth for 160 million years, until 65 million years ago, when a 10-kilometer-wide asteroid hit Earth at 20 kilometers per second. In that instant, the energy released equaled 10 billion Hiroshima atomic bombs exploding at once. The age of dinosaurs ended. Meanwhile, small mammals trembling in underground burrows seized a once-in-a-billion opportunity. They evolved, diversified, adapted. 6 million years ago, a group of apes stood upright and began walking on two legs. Later, they learned to use fire, craft tools, invent writing, and build dazzling civilizations. Eventually, they sent probes to Mars, and aimed telescopes toward the edge of the universe. That's us. But the story isn't over. When we look even farther, we encounter even greater mysteries. All the stars, galaxies, dust, and gas we see make up only 5% of the universe's total mass. Where is the remaining 95%? 27% is something we can't see or touch. Dark matter. It doesn't emit light or interact with it, but its gravity profoundly shapes galaxies. Without dark matter, galaxies would fall apart. Even stranger, 68% is dark energy, a mysterious force driving the accelerated expansion of the universe. In 2025, scientists released new findings suggesting that dark energy may be weakening over time. This means the fate of the universe may be far more uncertain than we imagined. So what is the universe's ultimate destiny? One possibility is heat death. The universe keeps expanding. Stars burn out one by one, black holes slowly evaporate, and everything fades into eternal cold and darkness. Another possibility is the Big Rip, where dark energy grows so strong that even atoms are torn apart. A third possibility is the Big Crunch. Expansion stops, the universe collapses. All matter converges into a single point, and another Big Bang ignites a new cosmic cycle. Imagine this. Every atom in your body is gathered together during cosmic collapse, then redistributed in a new Big Bang. In the next universe, those atoms might become another star, a tree on a distant planet, or a person in another civilization. This is how the universe works. Over 13.8 billion years, it turned stellar remnants into you, and gave you the ability to think about it. And what you're doing right now, reading these words, pondering these questions. Is the universe becoming aware of itself? Carl Sagan once said, "We are star stuff." That isn't poetic metaphor. It's cold, hard science. Every atom in you, once burned in the core of a star, was scattered by a supernova, and drifted through interstellar space for billions of years, before finally assembling into you. So the next time you look up at the night sky, remember this. You're not just seeing the universe's past, you're seeing your own origin, and the future of the universe is hidden in every question we dare to ask.